All right, this was the review. So 1 is not on your test. Should have whited it out. It's about a sphere. We haven't gotten to spheres yet. Don't worry about that one. Okay. Number 2 says explain the relationship between the height of the parallelogram and the bases. So the height's got to be the perpendicular distance, obviously in your own words. But the bases, you can, depending on how you draw your parallelogram, really the slanted sides doesn't really matter. But one pair of opposite sides would be the bases, and then the perpendicular segment connecting those two bases would be your height. Number 3, the apothem of this square was xz. Number 4, the radius of this square was xy. Number 5 says to find the diameter of them. So if it's giving it to you in decimal, this would be one of those that you would be using your calculator on. Okay, because it's given you in decimals. If circumference equals pi times d, 94.24 would equal pi times the diameter. Divide both sides by pi. And I would have gotten the diameter is about 30 feet. So it didn't indicate what to round to on your test. It will say round to the nearest tenth. So make sure that you know the tenth is how many decimal places? 1. Quick review on rounding. If this says 1-3, what does that round to? 30.1. If it says 30.15, what does it round to? 30.2. If it says 30.99, what does that round to? 31. The 9 rounds up the 9, the 9 rounds up the 1. This would be 31, okay? 31.0 technically. Sorry, no. So it's going to say round to the nearest tenth. Yep.
Okay.
On the ones that don't say, keep it in terms of pi.
For any time we do any multiplication.
For now.
Every step?
I wouldn't round until you get to the very end.
Okay.
So good question. Every step along the way, are you rounding? No, wait till you get to the end to round. Every time you round, it makes your answer less accurate. Okay, number 6 says to find the circumference of F. So this is your arc length. Notice it says centimeters and not centimeters squared. That's how you know the difference between length and area. Also, that would have been shaded in if it's the area. So the length equals the measure of the arc over 360 times the circumference. If the length is 5.5, 35 over 360 times the circumference, this is one you would have on with your calculator. You can reduce the right side, or you can immediately multiply by 300 over 35 on both sides. 360, sorry, over 35. And the circumference should have been 56.7 centimeters.
56.6.
So it's technically 50. Oh, I'm sorry, that's a 5. I can't even read. It's 5.7, not. That should be 56.6. Totally read it wrong. Yep. Yeah. Be careful. You should be using the pi button on your calculator, and there's no rounding there until you get to the end. So you won't lose a lot, but you're going to lose some. If that was a standardized test, you lose the credit. So you got to be careful. You got to make sure that you're rounding right.
What did you do 360 over 35?
I just multiplied by the reciprocal. But I could have multiplied by 360 and then divided by, because it will cancel from here, right? This would cancel from here. You could do it in 2 steps or together. But I want to get rid of the 360 and the 35. Okay, number 7, find the length of arc GH. So this is one that would be left in terms of pi. God bless you. Length is the measure of the arc over 360 times 2 pi r, which is your circumference. Measure is 115 over 360 times 2 times pi times the times the radius, which is 13. I can reduce this any way you want. So 2 goes into 360 180 times. And then 5 goes into each of these. This would be 23 times, 36 times, 23 over 36 times pi times 13. And you can use your calculator to do the math, but don't keep this in terms of a decimal. So 299 over 36 pi. So that's one, like it will say it in the directions, but you will keep it in terms of pi. Okay?
But what if you, I didn't see anything.
So, I mean, the review is the review. It didn't say it. On the test, it's going to explicitly say keep it in terms of pi. So if you use your calculators on those, you will lose credit. Just be really careful. Okay?
So you just, like, you can use your
Yeah, I mean, if you want to check your work, if you wanted to do 115 divided by 5, I don't have a problem with it. But you can't leave me decimals and use pi
okay,
on ones that say leave in terms of pi.
so like don't multiply or divide the fraction.
Correct. You're then rounding, which is not exact. You don't want to round.
But you want it in the simplest form.
Yep. Always. Yep.
How many questions is that?
15. Okay, 11.2 was the areas of the sectors and circles. Okay, number 8 said to find the area of the blue shaded region. So area would have been the measure of the arc, which is 240, over 360 times pi r squared. This would be left in terms of pi as well, so I can reduce by crossing through the zeros. Both 6 go into, actually 12 goes into both 24 and 36. 2/3 times pi times 81. 3 goes in 81, 70, 27 times. This would be 54 pi inches squared. So remember, area is inches squared, or whatever the unit is squared. Questions on that one? Okay, number 9, area of a shaded region. So what is the large shape? Rectangle. What is the small shape? Half of a circle or a semicircle, right? So I can find the area of the rectangle and subtract from it the area of the semicircle, which would be 1/2 of a circle. So you could either use the area of a sector on that one and do 180 over 360, or you could find the whole area of a circle and just cut it in half, whichever one makes the most sense to you. So rectangle would have been 4 times 6, which is 24. And the whole circle, if this whole side is 4, then a radius is 2. This would be 2 squared times pi, which is 4 pi. That would be a whole circle. So cut it in half or divide it by 2. And that area, this white part, is 2 pi. So if it said to keep it in terms of pi, it would be 2 minus 2 pi inches squared. If it said to use the calculator, it's 17.7 inches squared. 24, I wrote the wrong thing. 24 minus 2 pi inches squared.
How do you know it was 2 pi without doing the length?
I just took, that is exactly half the circle. So if you find the whole area of the whole circle and then just cut it in half.
Wait, why would you?
Yeah, but like, how did you know that 2 pi was? Because I did the like 180 over 360 times pi squared.
So pretend as though this was a whole one, right? This segment over here would be the diameter, would have been 4, which means that the radius would just be half of it, which would be 2. And then I could have found the area of that whole circle would have been 4 pi, right? Because pi 2 squared. And then cut it in half because it's only half the circle. You would have gotten the same, you should have gotten the same thing either way. Because 180 over 360 would have reduced to the 1/2. Okay, 10 is a circle, and it's this. The directions said to find the area of the blue shaded region. So I can do the whole circle minus the area of the red part, or I could work backwards because it's actually giving you the area of that little red part, right? I could have also figured out what the radius is and then done 360 minus the 50 and done the area of the sector. The first way is way easier, okay? So if I have the area, again, pay attention because this time it says feet squared. That's why you know it's area. It's also shaded instead of the length of the arc. So if the area of the sector equals the measure of the arc over 360 times pi r squared, and this is 27.93 equals 50 over 360 times pi r squared. Cross through my zeros, make it easier on myself. I would have a calculator for this one because it's in decimal form. 27.93 times 36, because I want to get rid of it here, would give me 1005.48. equals 5 pi r squared. Divide both sides by 5. I get 201.096 equals pi r squared. Divide it by pi. R is 64.01. R squared, sorry. And then square root it. And R is 8.00006. So we're going to say that that's 8. So that's the radius. It still wants the blue area, right? So I can either find the area of the whole circle and subtract from it the red, which I already have. It's going to be a heck of a lot easier. Or I can do area of a sector using 310 as the measure of the arc. Either way, you should get the same answer. So I'm going to do area of the whole circle minus the area of the red sector. So the whole would be pi 8 squared, 64 pi, minus 27.93. 64 pi minus 27.93, and you get 173.2. Questions on that one? Okay, then we get to 11.3, and then I'll go back to the other areas. So this one says a platter is in the shape of a regular octagon. Find the perimeter and the area of the platter if the apothem is 6 inches. So octagon, how many sides? 8. Okay. Central angle, 360 divided by 8 is 45. Cut it in half. 22.5. So that little triangle in there, 22.5, and it gave you the apothem, right? That's what it gave you. Apothem was 6. Thank you. Is an octagon one that you can do with your special right triangles? No, which means trig's going to get involved here. Okay, I don't need the radius, so I don't need the hypotenuse of that little right triangle, but what I do need is this length, which will end up being half of my side length. So in respect to 22.5x is what? Opposite. 6 is. 22.5 is that top angle, because it's 360 divided by n divided by 2. So I heard it, but it was adjacent, right? 6 is adjacent. So what trig function should you use? Tangent. Tangent of 22.5 equals x over 6. And then I want to multiply both sides by 6. So this is 4, 8, 5, and so on and so forth. So these I'm going to round because I'm going to just plug it right into that formula. So that's this half. If I multiply it by 2, I get the whole thing, which is s, which is 5. And the apothem they gave me was 6. So perimeter is n times s. 8 times 5, which is 40. Area, 1/2 ANS or AP, since I already have the perimeter. 1/2 6 times 40, which is 120. And the measurement they gave you was inches. So it would be 40 inches for the perimeter and 120 inches squared for the area.
So I did a tad bit different. But I haven't seen it.
How'd you do it differently?
I don't know, I've been doing it the same.
Okay.
Okay, good. It's just,
I just don't know any other way to do it. Like, are you finding the radius, maybe?
Can't even find one.
I got my apothem. I can't so tired. I got my apothem. I got my side, but I didn't do like the height. I mean,
That is the apothem.
I meant. You know what? I don't know.
Okay.
I'm just gonna accept it. Okay.
Hopefully you know how to do it again that way tomorrow and also get it right.
Yes.
Yeah, okay. Alexis.
What was that?
The 2.5 is the little section that's half of your, so it's this section here. It ends up being half of your side, but it's the opposite side of the 22.5.
Okay, so that's what we double together.
And then you double it to get the side. Exactly.
And what was n?
N is the number of sides, 8. Okay, so 12, a jigsaw puzzle is in the shape of a regular pentagon. How many sides does a pentagon have? Find the area of, if its radius is 17 centimeters, so this is 17, and its side length is 20. So this whole thing is 20, which means we already have the 20. So if I drop down the apothem this time, what happens to that 20? It's 10, okay? Do I have to use trig here? No, you can use the Pythagorean theorem, right? Could you use trig? Yes, I could do 360, divided by 5, cut it in half, get the top angle. Or I can say that the apothem squared plus 10 squared equals 17 squared. So you can do it either way. So a squared plus 100, 289. A squared would equal 189. And the square root of 189 is 13.7. That's going to be the remaining side, which is your apothem. And then it said find its area. So this time I can go straight to A and S. 13.7, number of sides is 5, length of each side is 20. Alejandro. So did you do trig? Yeah. So it's going to be a little bit different. That's actually more exact because we're rounding. But as long as you have your work to back it, that's totally fine. This would be, so you got 685? Oh wait, did I just do it wrong? I was talking and typing at the same time. 0.5 times 13.7 times 5 times 20. 685. Trig, right? 360 divided by 5 divided by 2 makes my top angle 36. And then this is 10, and I want this side this time. So tangent of 36 equals 10 over x, and I would do 10 divided by the tangent of 36. And this way, 13.8 is what it rounds to. So that's actually more accurate than the Pythagorean theorem. Okay, and technically, if you kept it as 10 tangent 36, that's the most accurate answer you can get. As long as you have the work to back it, then it's fine. So if it's that case, then it would have been 1/2 13.8 times 5 times 20. Well, I think twice times 20. And that's 690. So just make sure that your answer matches your work if you're rounding. Most likely you're not going to have the choice. It's going to be forced trig or it's going to be forced one of your special triangles. Yep.
How many trig questions are there going to be on the test?
1, maybe 2.
Trig questions? 2?
1, maybe 2.
How many tangent?
That's what they just asked. Yeah, 1, maybe 2. All right, triangle with side length 3, 4, 5. So what do I know about a triangle that has side lengths 3, 4, 5? It's a triple, which means it's what kind of triangle?
Right.
It's a right triangle, okay? Which means that 3 and 4 are your base and your height. Does that make sense? Okay, so 1/2 4 times 3, which is 6 units squared. Okay, number 2, a rhombus with diagonals 4 and 6. So the area for the rhombus is 1/2 diagonal 1 times diagonal 2, 4 times 6, 2 times 6, which is 12 units squared. Number 6, an isosceles triangle with sides 10, 10, and 16. So isosceles, two sides the same, 10, 10, 16. We need the height. What happens to that 16? Becomes 8 and 8. Do we know a triple that's something? 8 and 10? 6. So the height would be the 6, the base would be the 16, 1/2 16 times 6, or 8 times 6, which is 48 units squared. Still with me? Yeah? Okay, 8. So it's kind of drawn there to help you out a little bit. But if I divide this into two shapes, what's the top shape? Specifically, what kind of triangle? Isosceles. What's the bottom?
A rectangle.
Rectangle. So the area here would be 4 times 8, which is 32. This would have been 8. Split it. It's 4 and 4. The height is what? 3. 1/2. 8 times 3 is 4 times 3, which is 12. That's the top. 32 is the bottom. Add them together. 44 units squared.
I got 96.
Number 12. Equilateral triangle with perimeter 18. What's true about an equilateral triangle? All sides the same. So this would be 6, 6, and 6. So you actually have two ways to do this. Okay. One, cut it in half. That's a 3 and a 3. Find your height and do 1/2 base times height. What's another way to do it? 30, 60, 90 triangle. What's another way to do it? So add the third way in there. That was the first way. Yeah, the Pythagorean theorem will get you the height. It's also a regular polygon, so you could have used 1/2 A and S, right? Or 1/2 A times P. Do whatever's the easiest for you. So if this is an equilateral triangle, this is 60, this is 60, we just cut the top into 30 and 30. So if 3 is 30, opposite the 3 is X, opposite the 60 is? Good. A root 3, X root 3, whatever you want to say, okay? So this would be 1/2 base, which is 6, times the height, which is 3 root 3. This will be one that you will leave exact, okay? Because it's one of your special right triangles. Special triangles. That's 12. It will leave it. It will say the directions will specifically state for the numbers blank through blank, leave your answers exact unless it states to round. And so something that wants you to round will say an area with a blah, 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 round to the nearest tenth. If it doesn't say it, it's exact. All right, number 14, a rhombus with an angle of 120 degrees and size of 6.
But it makes sense that
Good.
it's like opposite sides.
You do the right triangle.
Yep. So if this was 120 degrees, let's go back the other way. If this is 100, just the way I drew it, I would have made these the obtuse ones, right? If I want a diagonal, I could cut it that way. Okay? I can also cut it the other way.
The other way is this.
What happens with a rhombus and its diagonals? It bisects those angles. So this is 60. What else happens? They're perpendicular. So this is a right angle. This is a 30, 60, 90 triangle. Opposite the 90 is your 2A. So this would be 3, and this would be 3 root 3. So I can even find the area of the 4 triangles and add them together. Remember this example from when we did it in the notes. We said you could find a rhombus as a parallelogram, you could find a rhombus as 3 triangles, or you could find the rhombus as the rhombus, which is 1/2 diagonal 1 times diagonal 2. So this would have also been 3 root 3, making this diagonal 6 root 3. This would have also been 3, making this diagonal 6. So this is 3. That's 18 root 3.
What are we going to do now?
Okay, 10. I'm not done. 10. An isosceles triangle with base 10 and perimeter 36. So isosceles means these two are the same. If the base is 10 and the perimeter is 36, what's true about the other two side lengths? How do you know they're congruent, right? And they're 13 because if I take the 10 off the perimeter, I get 26 divided by 2. 13, 13. Now I need the height. What did I just do to the bottom? 5 and 5. What's my height? 12. 5, 12, 13. 1/2 base times height. 5 times 12, which is 60.
Wait, what number was that?
That was 10. Okay, 16. Equilateral triangle with height 9. What? Right, we found it. So the base was 10, sides were 13, cut it in half, it's a 5, a hypotenuse 13, which means the height is 12. Here on this one, right? So this is an equilateral triangle, 60, 60. This would be 30 and 30. Opposite the 30 is your, I'm going to say this is x, so we don't confuse it, x. This is x root 3, and this is 2x. So if 9 equals x root 3, divide by the root 3, rationalize it, and you get 3 root 3. So that's this segment here, which would get doubled for its base. Now I already have the height. So a half of 6 is 3. 3 times 9 is 27 root 3. $18, a regular hexagon with perimeter of 60. So this is the first regular polygon we've done. That's one of the special right triangles. Hexagon, which has how many sides? Okay, if I make my central angle on a hexagon 360 divided by the number of sides would be 60. Cut it in half. What's the angle at the top? Okay, it says the perimeter is 60, which means good. So this whole side is 10. In a 30, 60, in a 30, 60, 90 triangle, this is my x, this is my x root 3, and this is my 2x. So if that whole side is 10, then this is 5, and the apothem on that hexagon is 5 root 3. So the area would be 1/2 the apothem times the perimeter, which I can either use the perimeter that they gave me or multiply it back out. It doesn't matter either way, I get the same thing. 1/2 times 60 is 30. 30 times 5 is 150 root 3. Which will be left exact. Okay, that's an exact one. So circle, rectangle. Length is the longest side. So depending on how you drew it, if you drew it tall or if you drew it wide, it's up to you, but length would be the longest side. And the diagonal, 10. What do I need for a rectangle? What's the base times height? I have the base. I need the height, okay? Oh, a radius of 10, I'm sorry. I read it wrong. So this is 10. Which means the diagonal is what? 20. Well, that makes sense because the hypotenuse can't be bigger than the side anyway. All right, so I need this side, which is my h. Pythagorean theorem. H squared plus 16 squared equals 20 squared.
Wait, are you able to use like the diagonals to find the area of the or is it just based on
It's the only way, because a rectangle doesn't have to be a rhombus. If it's a square, you can use either one. So 256, this is 400. H squared is 144, and H is 12. $192. So a good question just came up. I don't know if you guys heard it, but he said, could you use the 1/2 diagonals, 1 times diagonal 2 on a rectangle? Is a rectangle a rhombus by definition? No. But what else is a rhombus by definition? A square. So should you have a square with a diagonal, you can use 1/2 diagonal 1 times diagonal 2. Those diagonals are the same if they're the square. And then it saves you time. Does that make sense? So if I just gave you and said this is a square, right? I would have to know it's a square. Find the area. It's 1/2, 20 times 20. which is a lot easier than doing the 45, 45, 90 triangle on it, okay? Because if it's a square, it's a rhombus. Does that make sense? Yeah? Okay. All right, so I'm going to open up extra practice. If you do it, if you need to do it, do it. My advice is do it. The answers will be posted, okay? Tomorrow's your test. Make sure you have a calculator.